Howdy. We're going to talk about dilations today. This is 721, it's dilations. So we're going to start out with the dilation. A dilation, just like your eyeballs, they get bigger and small. That's called dilating your eyeballs. A dilation is nothing more than that. You're dilating a figure. You're either making it larger or you're making it smaller. So in our case, we're going to make dilations. So we're going to start out every dilation has a fixed point called the center of dilation. It is located where the lines connect the corresponding parts. So what you'll have is you'll have a center of dilation. In our case, that center is always going to be the origin. When you hit algebra, that center of dilation is going to be other points, but you can really find them pretty easy. You'll notice if you draw a line from the center of dilation, in our case, the origin, and you connect it to one point on the pre-image. The pre-image is the one without apostrophes. You connect it to one point, you'll get a straight line. Every reduction or enlargement and every dilation will fall on that point. So point A, even if I reduce it or enlargement, that point for the image will always fall on that line. When you get to algebra, that's one of the ways you can find the center of dilation is just draw lines and connect and find out where they do. So a dilation can produce a figure that's either an enlargement where it gets bigger or a reduction where it gets smaller. Oops, there's my reduction. It's hard with your hands. And we talk about, when we do this, we talk about scale factor. Scale factor describes how much it's enlarged or reduced. And think about this. When we talk about scale, if you've ever done modeling and you make a car and it's 1/35th scale, which means the car you get is 1/35th the size. Actually, I got a car up here. Or maybe I can get it. Maybe I can't. Oh, I dropped things. So I have a car. It's right here. It's a GTO, and it's 1/35th scale. It's still in the package, so it's still valuable. This GTO is 1/35th scale, which means if you got one of these and you blew it up, and like Willy Wonka machine, you could blow it up 35 times. It would be the actual size of a car. So that's 1/35th scale. So scale factor is how big or how small. Um, if the scale factor is larger than 1, it is an enlargement. It got bigger. Now, a scale factor of 1 is the same size. That's a trick question if you ever see that it's the exact same thing. It doesn't change, it doesn't locate, it doesn't relocate. If the scale factor is less than 1, meaning a fraction like 1/2 or 3/4 or 1/4, it means it got smaller. It shrunk by that amount. If you throw a nice shirt in the dryer on high heat, the scale factor reduces to like 3/4. When you put it on the next time, it doesn't fit. So that's a scale factor. So let's look at some problems. Our first one says, find the scale factor of the dilation. Is it an enlargement or a reduction? So let's look at A, and I'm going to attempt to use a pointer device, which I'm not doing real well with today. So here it is. This, come on. Why is my pen not working? Oh, now my pen's not working. Oh, well, my pen's not working now. Well, it worked before, but it was too easy, right? So this, because it has no apostrophe, remember it's my pre-image. And this is my image. It's got an apostrophe. And now, if I was to draw a line from the origin and I was to run that line through the image, I would come up with the apostrophe. You'll notice that as I drew that line, the image or the pre-image was inside of the image and smaller. That means the image itself is an enlargement. So the first thing we'll have is that is an enlargement. I'm just going to put an E here. So what's the scale factor? Why is my thing not? Oh, well. So what's the scale factor? The scale factor we can determine pretty easy, And the way we do that is let's look at point A. And you really only need 1 point to find scale factor. And I apologize for slowing down there. I'm trying to make stuff work here. If I look at the point for point A, my point is at -1, comma 2. So -1, comma 2. Now let's look at A itself. So when we look at A is at -3, comma 6. So A is at -3, comma 6, and this was -1, comma 2. Let's look at it. So if I divide, I'm going to take my original here. If I divide 1 by or -3 by -1, I get -3. If I divide 6 by 2, I get 3. So my scale factor is 3. Anything there. And let's look at point 2 or point B. So point B is at 3, comma 1. Now, if I did this right and it's a scale factor of 3, when I multiply 3 by 3, I should get the image for B. So B apostrophe. So 3 times 3 is 9, and you'll see that this is definitely 9. And then I'll do the same thing with the y coordinate. 3 times 1 is 3. And that definitely matched up here too. So it's 3. So my scale factor is 3, and it's an enlargement. Let's look at B here. So again, I'm searching to find out which one's the image and which one's the pre-image. So this is the pre-image. It's got nothing on it. And this is the image. If I was to draw a line through the center of dilation and run across the image, you'll notice that D apostrophe is smaller. It's inside that. So this is definitely a reduction. How much did it reduce by? The same thing we did before. We'll take and find the coordinates. So D, the x coordinate is 4 because it moves across the bottom. Always move left to right first. 4. And the y coordinate is 10. So going down here, D apostrophe, the x coordinate is 2. And the y coordinate is 5. Well, we know it's a reduction. So let's divide 2 by 4. I'm always going to divide the image by the pre-image. Always divide the image divided by the pre-image. The pre-image, that's really terrible. I'm sorry, I'm trying to write with a mouse. So I'm dividing the image by the pre-image, and that's 2 divided by 4. Well, that equals, if I simplify that, that's 1 divided by 2. Now, for those of you who don't have your calculators, if you've got phones, I would use Math Ally. It's what I download for mine, and the other good one is Desmos. Desmos would work here exceptionally well, but it has a high learning curve. Well, let's check. So those are 2 that you can get. Let's check here. So, doing the same thing, the image divided by the pre-image. I do 5 divided by 10. Well, 5 divided by 10 equals 1/2. And that's the same I had before. So this one, it is a reduction by 1/2. All right, so now let's clear the screen. If I figure out how to wipe the screen, there we go. All right. So let's move down a little. Whoop. Let's move down to. It says you dilate a figure using the origin as the center of dilation. Multiply each coordinate by the scale factor. That is as hard as this gets. So if the scale factor is a number greater than 1, it's an enlargement. You just multiply. And that one's pretty fast. If the scale factor is a reduction, it's the same thing. You multiply. So let's look here. I got a scale factor of 2. Most of your scale factors are going to be in small numbers like 2, 3, or 4. I determine the image points. So the vertices of the pre-image are A is 1, comma 2. B is 2 comma 0, and C is 3 comma 3 were the vertices of A apostrophe, B apostrophe, C apostrophe. Well, A apostrophe, all I'm going to do is multiply the coordinates by 2. So 2 times 1 is 2. 2 times 2 is 4. That's A apostrophe. Now I go to B apostrophe. So B apostrophe, I was trying that pen again. I'm going to get 2. Well, 2 times 2, my scale factor is 2. So 2 times 2 is 4. And then Y is 0. So 2 times 0 is 0. So B is 4 comma 0. And then my last one is C. And I get C is 3, 3. So C apostrophe is 3 times 2 is 6. And 3 times 3 is 6 again. So there's my coordinates. A apostrophe is 2 comma 4. B apostrophe is 4 comma 0. And C apostrophe is 6 comma 6. So dilations do retain their proportionality. When I do a dilation, I'm just changing the size of the thing. I'm not changing the orientation. I'm not changing individual size. It remains a proportional figure. If I make one side bigger, all the sides get bigger. It retains its proportionality. That means I can use a ratio to figure out what's going on. So let's look at these. I've got a triangle called MNO, and its sides are 4, 5, and 6 centimeters. Now I've got a triangle M apostrophe, N apostrophe, O apostrophe, and its sides are 12, 15, and 18 centimeters. That should be an is there, triangle MNO a dilation? I love it when I find errors in the middle of that. Well, let's look. So I'm always going to do image divided by pre-image, right? So here I've got image is 4 divided by pre-image is 12. So what do I got? I got 1 over 3. So that's the ratio. Oh, I did that backwards. Well, let's erase that. I'm a dork. Because I did exactly what I say to worry about. I took the pre-image and I did the opposite. So it's image, which is MNO. So that's 12 divided by pre-image, which is MNO without apostrophes. Remember, the pre-image has no apostrophes, divided by 4. So 12 divided by 4 equals, well, 12 divided by 4 is 3. Now, if this is a dilation, then every side will have a ratio of 3. So let's look at the next one. I've got 15, so my next side is 15, and its corresponding side is 5. Well, 15 divided by 5 is 3. Well, that's exactly what we wanted. And then the last one, I've got 18 divided by 6. Well, 18 divided by 6 is 3. And that's right. So yes, this is a dilation. I'm getting better at writing this way. So yes, this is a dilation. All right, so your homework will be done using forms. Don't rush it. I always am terrified with forms that you guys are going to rush through it. Don't do that. Go slow, check your answers. If it's wrong, you can correct it until it's right. Some of these are going to require me to check it, so you're going to have to wait till I get around to checking it for you to make corrections. Good luck.